All right, guys. While you're setting up laptops, I'll get started because we don't actually code for a little bit. So. What? Ah, that's great. All right. So if you guys don't know me, I'm Marcus. I'm interning with Mr. Epley. I'm in his fourth period AP Computer Science class. And today we are going to learn how to make games. Well, I mean 2D games from scratch in Java, which is pretty cool. This first lesson is we're not actually gonna have something that's a full game. It's gonna be multiple lessons. And if you miss any of the lessons, I'm not sure what the schedule is going to be yet, but if you miss any of the lessons, all this will be recorded. One question, is anybody here not okay with this being recorded? There's no, I'm being video recorded, but none of, other than audio, none of you being recorded. So we all okay with that? Or anybody object? It's okay to object if you do. Okay, cool. So let's get started then. You need computers pretty much. You can get notes, or you cannot if you want, because this will be recorded. Kind of just some stuff what we're going to be doing. Our goal is to get some sort of platform, pretty much, that you guys can actually work from. Like, I don't want to just give you code that you copy down like a lot of people do online. I want you guys to have something that you can just figure out how to make stuff work with. That's kind of what programming is, not just copying. So if you know Realm of the Mad God, this is kind of something that's within our range, something that's kind of like a 2D game. There's a lot of interesting things to do in Realm of the Mad God. I don't know if you ever played it. Also, I'm hoping at some point to get into like the side-scroller stuff, so physics engines as well as graphics engine, because you need gravity and stuff. For your workspace, for today, nothing really is needed other than Java. But I recommend for next lesson and lessons after that to get something like Sublime or Notepad++ or something running. And if you're using one of the school's laptop, I believe they do have a portable version of Sublime Text that you can put on a flash drive. And this is simply because eventually it's going to get annoying tabbing in and having to space all the time instead of just pressing tab. I know there's ways to get around that, so whatever works for you. Here's just some of my suggestions. So, let's talk about it. Hold on a second. So one thing we're going to be working with is, we're not working with the whole time, but we have to sort of get an actual frame in Java, because everything that you guys have done, at least in AP Computer Science, has involved just the console. We need something to come up that we can actually draw graphics to. We need a frame, and that's called a JFrame. Graphics library in Java is gigantic, and I don't think the person that created it, I don't think anybody knows everything about the graphics library in Java without consulting something called Java. That's giant. Oh my god. Let me figure out how to make that smaller. I think I did it. Okay. So anyway, I would recommend searching either online, just Javadoc 8, or I downloaded the whole thing. You can download the whole thing online. And I'm just going to go ahead and find JFrame, and that is something we're going to be working with. And as you can see, here's the hierarchy. The Javadoc is so useful. And if you really want to learn how to program, instead of just searching Stack Overflow, really just go to the Javadoc, because the Javadoc for Java will teach you everything. It'll show you all the methods, show you everything you need to know, and then you can figure out for yourself how to implement those. And if you're still lost, then of course you can Google it, but I'd recommend using the Javadoc first. So yeah, first of all, here's all the stuff it extends. And if we go down just to some of the stuff it has, it's absolutely ridiculous. So unfortunately, I'm just going to have to show you the stuff we'll be using, because we actually will be making our own type of graphics engine. We won't be using that much of stuff that Java gives us. So let me go ahead and just search. First of all, let's go ahead and start working with this. Let's just get I opened Visual Studio. Hold on. Wait for that to load so I can close out of it. So here's my editing window. I'm gonna kind of program with you with this, because that's the way I like doing this. But anyway, let's go ahead and save this first. Create a file, however you want to save it. I'm just gonna save it as game.java. Whoa, am I? A little bit. So specific, yes. Sorry, my workspace. I'd create a folder for this stuff because we're gonna have a few different Java files eventually. But yeah, here's game.java. Such a descriptive name. You can name whatever you want, I don't care. So, let's get our brackets open. You guys, actually I'm going to do it the way you guys do it. I'll do it that way. So, you guys might remember, whenever you have a library that's a Java library that you have to use in your code, since it's not automatically put into your workspace, I'm sure you remember doing import, and then you would import something from Java, and then, for example, I think you used util, you used math in Java, and I think you just automatically had util.star, which just imported all of the utilities for Java. We're going to import the JFrame, and as you can see right over here, it shows us javax.swing.jframe. That's exactly what we want to import. So we're going to go ahead and do that javax, and this is before we even have our class constructor, our class public class game. So we want to have import javax.swing.jframe. I'll let you guys do that while I do something quick. Another thing I'm going to do is oh my gosh, I'm going to go to my workspace again here. I have game. I'm going to, if you're in Windows, if you're using one of the laptops here using Ubuntu, just open a terminal. But if you're in Windows and you shift right click, it'll actually say open command window here. If you click that, you'll have a command window here. And if you have your Java path set up correctly, hold on. Oh, it's over here. Okay. So, wow, that's really small. Yeah. But yeah, there it is. I'm just going to go ahead and, you can't see this, but I'm going to go ahead and compile it by doing java game.java to make sure it's all working, which it should. Yep, no errors. Okay. Another thing, if you're using Sublime Text, you can also do tools and then build. And actually builds it with Java because it detects what you're using. So I do Control B and then something pops up here. Do you have a problem? Oh, yeah, I need a main method. It doesn't see that I have a main method, which you need to start the application. So we're going to do that now. Public static void main string array of arguments, and I'm so used to doing it that way. The C style bracket orientation. I'm going to do it your way. So let me compile again. As you can see, I did Control Shift B, and Java C pops up for me. If you're using Sublime Text, if not, you just have to go to the console and compile it using javac, which works the same way. Okay, so there's two things we could do here to create our JFrame object. We can either actually declare it within here. But to be honest, I kind of want to keep everything outside of the main method because I don't want to make everything static. And you guys haven't really learned what static means yet, but static pretty much means it's accessible by everything, I guess is an easy way to explain it initially. So we just want to create a new game, and that's it. So now we've eliminated the main method. We're not even going to do anything with that, and we're just going to have everything inside of our game constructor. Does that make sense? You're loading the game constructor. By the way, if you guys have any questions at any point, just put your hands up and I'll let you know. Or if I'm going too fast, let me know. I did this again. So instead of creating a JFrame, I'm going to do a cool thing that we did before. And I'm actually going to make this our JFrame. So I'm going to go ahead and do extends JFrame. So now we're extending the JFrame library in its entirety, which is over here. So it's like adding on to the hierarchy. And now, if we compile, that should work. Yep. I'm going to call a method that's within JFrame. I think if I search it, set visible. Let me turn my sound off. Set visible. Yeah, it's down here. See how many methods there are? It's ridiculous. So we're going to go ahead and do set visible true. And this is just kind of something that you kind of need to know. Just it works. I can't really like explain the whole library. But if we run, which I just ran the application, like you would do compile then run, you get this. I can even move it over because you get like a small window here. So we actually have a window now. And actually I had to resize it. It started out like this because we actually hadn't given it a boundary yet. It doesn't have any size. We're going to go to here. And right before set visible, which actually sets it so the person can actually see it, we're going to do another method called set bounds. And set bounds has 4 parameters. And actually I'm going to go to the Let me go to the prints of this in JavaDoc. Let's look at set bounds. There it is. Okay, so set bounds has 4 parameters: x, y, width, and height. And I'm getting this straight off the JavaDoc. X is the new x coordinate of this component relative to the screen. Y, the new y coordinate of this component, also relative to the screen, width and height of the component. So right now I'm just going to do 0 and 0 as the x and y starting position, and whatever size you want. I'm going to do 1,000 and 800. Why not? Anything works. Compile that, and here I'll use. Oh, it keeps popping up on the wrong monitor. But here it is now. It is a window, and it automatically sized itself. So now we have an actual window in Java. And
actually do that.
Yeah, yeah.
And what he has, and actually compile it, and then Java run it, just like we always do, and then see the window pop up. See, he's on 2 different screens, so that's why he's doing dragging it over so that you can see it. But you can be doing all this, right? So just create your file, type all that stuff in, and do like we always do. Compile it, run it. You'll get a window to pop up. So raise your hand if you'd like a couple minutes to actually do that. If you haven't already done it yourself, raise your hand if you need a couple minutes to actually do that. Nobody? Everybody's already done it themselves?
okay. So yeah, I'm not going to just explain everything about the library as I said before, but we're going to go ahead and test out a few things. There's a method within JFrame called paint. Oh, this is like off the screen. And we're going to use that to test out a few things. Paint, here it is. So paint is a method that takes something called graphics, or it gives you something called graphics. So this is a method we're going to put in here. And we're going to extend it to the JFrame library by default, and it's going to call paint. I think it says here. Force the paint to any lightweight. Force the paint to any lightweight components that are children of this container. It's telling us we need to do this. To call the paint method of the super class, so the class that we're extending, and call the paint method of JFrame. And yeah, that's it. So this is going to be called to paint the method to the screen, or paint the graphics to the screen. So we're going to go ahead and between here, we're going to do public void. Let's get this. And then graphics, and we can call these graphics. Lowercase, of course, we need the graphics capitalized. And one thing, as well, we need to import the graphics library. Right now we have the JFrame imported. So cool thing about JavaDoc, it has a hyperlink right here on graphics. If we click on this, it shows us exactly where it is. So we need to import java.art.graphics. So I'm going to do that up here. I like to keep my imports in alphabetical order. So you'll end up having quite a lot of imports up here. And want to keep those in alphabetical order. You might be thinking, why don't you just do import java.star? And that's just really bad practice. But you can import sublibraries.star, but you can't import the entire Java. Yeah. But I just, I was giving an example of something that's bad practice because it's just, you don't need everything. And if you do that, there's actually libraries that have different, they have something named the same that is different, so you'll end up having a lot of problems. Which I think is the reason why you can only do that with sublibraries. So anyway, let's go down to our paint method here, now that we have graphics installed. Actually, let's go ahead and compile quickly to make sure that works. And it looks like it did. I'm not going to run it because it's good. Now, one thing it told us to do, and this is the reason why we definitely want to use the JavaDoc. Let me go back. Is it told us to super.paint before we do anything, because otherwise we'll just have some problems with the other components. So we're going to do that. We're going to do super, because super means we're calling the extended object. So we're calling JFrame. This is right here. This is the JFrame that we're extending. We're going to do super.paint, then pass in our graphics. It's going to do the same thing. And then afterwards, we're going to do the stuff that we want to do. So there's a few things that we can do with graphics. Let's go to the JavaDoc. And don't worry, I won't be going through the Java doc in every single lesson. We just kind of want to get something started here that we can work with. So this is probably one of the most annoying starts, I think. The only really annoying thing is starting, I think, in my opinion. So let's go down here. It tells us what graphics is. It's an abstract base class for all graphics contexts, and that just pretty much means that other types of classes will extend this because it's abstract, and abstract means that it can't just create graphics by default. Yeah, I'm just going to add the methods here. It tells us stuff we can do. We can draw rectangles. We can draw images, which is probably what you're guessing. That's what we're going to do. We're going to draw stuff to it. So one thing we have to do first is there's another library that I'm just going to tell you we need to import. Let's go up here. This is an auth library, and it'll go before graphics in alphabetical order. It's import java.auth.color. And that's just, let's compile that, make sure. That's just the color, just imports color, allows us to set colors and get colors, and without having to figure out the exact ID for that color.
If you don't use the colors, what would the IDs be?
There's I think there's 60 million colors, and you just kind of have to figure out what that ID is. You do, I think in hexadecimal you can do 0xFF, or no, 0x and then whatever the hexadecimal code is. So if you found just hex on Google or something, and you found whatever the color was, you could type in whatever it is. Like for example, I think FF00FF, that's cyan. I don't know all of them though. I don't know, I just knew it.
What was the last one you used?
Oh, that was java.auth.color. So is everybody there? Put your hand up if you're not there yet. And you won't just be copying stuff the whole time, we just need to get something started here. So now we're going to do a few things in graphics. We're going to first of all call a method called setColor, and let's look at setColor first before we even code it. Where is it? Let's click on this. Okay, sets the graphics context's current color to the specified color, and all subsequent graphics operations using this graphics context use the specified color. So what does that mean? That pretty much means you're setting the color that you're going to be drawing stuff with. So when you call draw anything, this is the color it's going to use to draw that. Or fill anything or anything. So we're going to do graphics.setColor, and it had only one parameter, and that's the color code, and we're going to do color.red. Because we're calling our color library here, and the color has a bunch of static methods, or static, not methods, fields, of all the colors you can use, well, all the big, important colors. What? You can use, if you go to the color library here, here's all the colors, and for some reason they have them in caps and lowercase, so whatever your preference is. Here's all the colors you can use. And you see it says static because these are all methods that can be accessed without having to create an object for color. So yeah, I think this is, yeah, there's not many. Yellow, pink, red, whatever you want to do. Okay, let's draw something now that we have this. Let's go ahead and do graphics dot, and you can get any method you want off of that graphics Java doc, but I'm going to go ahead and do fill oval. And if I look at fill oval, parameters are an integer for x, integer for y, and this is the x and y position. And x is relative to the upper left corner of the oval to be filled, and y is relative to the upper left corner of the oval to be filled. So you pick the frame, and that's the 0, 0. It's like Cartesian coordinates in the fourth quadrant is kind of what you're doing, I guess. No, it'd be Cartesian coordinates in, I don't know. Yeah, it's just like it is in VB. There you go. So anyway, let's go fill an oval. Where's my mouse? There it is. Fill an oval. 200 or whatever you want to use. I'm just going to put in random coordinates to see if it works. And then the width of the oval, which is 50, I guess, whatever you want to, and then the height of the oval. There we go. Let's compile that. And I'm going to go ahead and run that. And it's on this monitor. Let me go ahead and put it over. And there we have our oval. So we have a game. We're done. Thank you. That is all you need to do. Now you do everything else yourself. No, I'm joking. So there's our oval. And one thing you'll notice, a few things, the paint method is called whenever the window is resized. So let me go ahead and show you what happens if you don't call the super method here. Some real funky stuff happens. Let's do that. I hate that it keeps popping up over here. So if we resize now, really bad stuff happens because other components aren't being painted. It's just our oval now, which we don't really want. So we can go ahead and call the super method. What was your question? Or are you just stretching? Just stretching here. So yeah, you can fill ovals, you can fill rectangles. Fill rect is the name because they like to cut everything off. So yeah, there we go, and that's drawing. But unfortunately, painting. This is kind of what you like. It's kind of what you did in VB. This kind of stuff. You just painted stuff to the screen. Yeah, what's your question?
Yeah. Why is the paint method called when you resize things?
Because any time that it needs to repaint the frame, so it doesn't automatically have to repaint it all the time if it hasn't changed at all. But any time it detects some sort of change to the window, it's going to repaint it to make sure everything's in the right place.
What does it choose that function?
What do you mean, choose?
The paint function that you were referring to paint.
Well, it's in the extended class, so it calls that in the extended class, and since we've overridden it, it's going to call that method instead. Oops. So yeah, that's kind of what we did in VB, but we're going to go down more into like the nitty gritty and just handling all the graphics ourselves. And there are some tools we have at our disposal for this, so we're going to get into some notes here if you are taking notes. If not, this will be recorded. So, so graphics buffering. Let's go ahead and put the computing definition for a buffer, and that is to store data in a buffer while it's being processed or transferred. And graphics buffering pretty much means we're going to have 2 or more arrays of screen pixels. So we're actually going to grab all of the pixels for our screen, and we're going to change those. We're going to change the colors of those pixels and put them back on the screen. And graphics buffering, well, we can do that without graphics buffering, but the user's going to see us editing all those pixels. It's going to see us drawing on the screen, and we don't really want that. We want that to happen in the background. Here's a little example. Let me go ahead and bring up something here. Whoops. It's over there. So here's an animation I found online. There's our buffer, and the object's being put on the buffer, and then it's put in the eyeball as us, and you can see it. And then it's switching the buffers. Here's an example of 2 buffers, but you can actually have more than 2 buffers. So let's get into that a little bit. So we're going to have 2 or more areas of screen pixels, as many as you want, really. There's a smart amount to have. You don't want to have like 50 buffers, because that's going to be work for you. One of the areas will be what we are showing on the screen. It's going to be what the user is actually seeing at the time. And one of the arrays is going to be what we're writing to. And the rest of the arrays are just going to queue up to be put on screen and then recycle to be written again. So they're all switched and everything's recycled to be used again. So that's right there. Everybody good? Okay, so here's a little diagram. I'm using 4 buffers here. We have what's on screen, we have buffer 1, 2, and 3, and they're all kind of cycling through. And I guess buffer 3 would be what we're drawing to here. And then buffer 2 would be just one of the buffers in queue for the screen. Yeah?
Why would you keep moving 2 buffers?
So sometimes the write operation takes longer than it would to switch the buffers. So it might take a little bit longer, so you want to make sure you have enough time you have enough buffers in queue. So they don't necessarily have to be, like this buffer 1 can be on screen, and buffer 2 doesn't have to immediately switch to that. Like it's kind of like a queue. It's like waiting in a line, waiting to be put onto the screen. So, yeah. And here's an example that we're going to be using. We're going to be using 3 buffers, actually for that exact reason, because what's on screen is there, and then we have 2 buffers, and sometimes it takes a little bit longer to draw graphics, and we don't want a stutter to happen for that reason, so we're just going to have a buffer to be sure that we don't have that stutter. I think what we're doing would probably work with 2 buffers, but I just use 3 buffers to be completely certain. So here's our graphics library. I think I explained everything that I already explained. Graphics is an abstract base class for all the graphics contexts, and that allows pretty much an application to draw onto components. So right now we're drawing onto our frame. We have no other component we're drawing onto other than just the frame. And as you know, abstract means that it needs to be overridden by something. So in order to actually create our graphics, we're going to be using Graphics 2D. Graphics 2D is an extension of the graphics class that allows control over geometry. This is exactly what I got from the Java doc. Control over geometry, coordinate transformations, color management, and text layout. And really the only thing we're going to use is color management. We're going to get the pixels and change the colors. We don't really care about the other stuff because really what we're focusing on is creating our own graphics library, not using what Java gives to us, but we have to use this. So that pretty much means we can manage the color of every pixel on the screen, translate, rotate, and scale the graphics, and print text on the screen at specific coordinates with a specific font. We're only going to use the first one, manage the color of every pixel on the screen. So buffer strategy is Java's own way to do graphics buffering. And thankfully, we don't have to create this ourselves. Buffer strategy already handles this for us. It's a mechanism to handle our graphics buffering. I say mechanism because it's still an object, but it's kind of like running in the background. It's helping us. It's kind of like the mechanism to put into our engine, like a gear we're putting on our engine or something, I guess you could say. And yeah, this pretty much allows us to swap and access our graphics buffers. So swap and access the graphics buffers we're showing on the screen and the one we're editing. And there's something else we're going to use because, as I said, the paint method in JFrame only is called whenever the JFrame is changed, whenever we resize. And I guess, yeah, you could say, why don't we just call it ourselves? But bad things happen because that means that every component is repainted and you get a flashy effect. So I'm going to use something called a canvas. And a canvas is a JFrame component that we can draw our graphics to, hence the name canvas. It's like writing, like drawing onto the canvas. I'm going to go ahead and close the door. So yeah, a JFrame component we can draw graphics to. It handles our buffer strategy. We just give it the buffer strategy that we create our object, and it handles all the switching. So that's all done in the background as well, which is pretty awesome. So yeah, do we have any questions so far about anything? It's okay to ask questions. Okay, and we can delve into the canvas. So, I'm going to go ahead and get back to Java docs. That's the animation. Oh yeah, actually I have something else to show you. If we don't use buffering, I'm having problems. Hold on. Let me move this over to my other monitor so I can actually do things with it. All right. Let me go ahead and show you this. The reason we're using buffering is so that the user doesn't see anything just drawn on the screen. It sees the full image. And here's an example of what happens if you don't use buffering. On the left is without buffering. On the right is with buffering. Now obviously our eyes aren't fast enough to actually really see that being drawn because it's a pretty simple image. But like you can see it's flashing because it's going through every single pixel and changing it, and we can actually see that happening. And with the buffering, it's just smooth because everything's being buffered and we're not seeing it being actually drawn to the screen. So that's why it's really important to use buffering. Why it can't just be something that's like, not necessarily required. It is required. Let me go ahead and bring up this. Let's bring up our Java doc. Okay, so let's go ahead and find Canvas. Here it is. So Canvas overrides something called component, and component is something we can add to a JFrame. So yeah, that's really all you need to know about that. The component is something you add to a JFrame component. And anything that says aught here, just to know, anything that says java.aught is to do with the Java graphics library, JFrame library, whatever you want to call it. Do you know what aught stands for?
Yeah, but it was the original graphic stuff of the very first version of Java.
Yeah.
And then as soon as the second version came out, they came out with a whole new library, but it still used some of the, I usually call it AWT.
Yeah.
Probably stood for something, but I don't remember what it is.
So anyway, we need to import our java.aught.canvas, like we did before. Did I see a hand? Sorry. Yeah. You need to import it. And that would go before color in alphabetical order.
AWT, Abstract Window Toolkit.
Abstract Window
I
Toolkit.
think I've ever actually heard that.
Yeah. Java.abstract window toolkit. Canvas. Yeah. Alright, now let's import it to make sure that we have that spelled right. We do. Compiled. Alright. So let's go ahead and I'm just going to go ahead and comment out our stuff we have here because we're going to do something completely different than Paint. In fact, we're just going to comment out the whole method so it doesn't override it and do nothing. So make sure you comment out that whole method. Or just delete it, whatever you want to do. And here, we're instead of extending Canvas, because you can't extend two things, and we're really not going to be doing that much within the actual Canvas, other than just getting stuff from it. We're going to go ahead and create a field for Canvas right outside. And remember how you declare variables. First of all, it's private because I don't want anything else to mess with it. And Canvas, capital C, is the name of the library. And then lowercase canvas is what we're going to be calling it within this class. And then that's equal to a new of type object canvas. And actually, I forgot to do one thing quickly. So one thing you might notice, if I run this, frame, and then when I close it, it's not saying it's done. Well, this usually says whenever it's done with anything, it comes up saying finished. So it's not actually closing when I close the JFrame. So we want to go ahead and do something quick. This is just something, just a method we have to use. Set default close operation JFrame dot, and there's a field in JFrame exit underscore on underscore close. Now, yeah, it's a mouthful of a method, and I'm not sure why it doesn't do that by default, to be honest. But it doesn't actually close the application when the application is closed. Well, I guess I can understand why it doesn't do that by default. So now if we were to run our application, which continuously pops up on the wrong monitor, and if we were to close it, it actually stopped running. So we want the application to exit on close. That's what we're going to do. So this, I probably should add some comments as well. Not makes, make. Set the position and size of our frame, that's what this does. Oh wait, no. Make our frame visible. Another thing that you just once again, I can't really explain because I just had to know this as well. Right now, I kind of want our frame to just kind of pop up in the middle of our screen, and right now we have to set the position of it. So it's just something you can do. Set location relative to is a method in JFrame, and this sets a location relative to another JFrame or component you might have. If you put in null here, if you put in nothing, it just puts it in the center of the screen. And I don't know why it does that, but it does. So we're going to go ahead and run that. And it's going to pop on the other monitor, so I can't show you, but it put it in the center of my monitor. It put it right there when I did that. So that's what we need to do there. So that's going to put our frame in the center of the screen. And I think now we're done with the really stupid graphic stuff to do with JFrame. So now we're going to call another method which is simple enough, and that's add canvas. All right, so there's a method in JFrame called add, and we're just calling that, and we're adding our canvas component, which we created up here. So this is all before the set visible. If you do this after the set visible, it won't repaint. So now we've set visible. What? Oh, okay. Let's actually go ahead and do some stuff in between here. And this is where we're going to do everything before we set the frame. I want the frame to be visible. So a few things you have to do, a few methods in Canvas. If I actually go to the Canvas, well, I'm in there right now. There's a few methods if you scroll down. It actually shows you, because I think it just assumes that everybody that wants to use this uses a buffer strategy. So it made it easy for us and told us, gave us a method to actually create the buffer strategy without having to initialize it ourselves, which I guess is easy enough. So let's go ahead and do that. Let's go ahead and call that method. I'm going to do canvas dot, and this is our lowercase c because this is our field of type canvas. Canvas dot create buffer strategy, and then there was one parameter it needed, and that was a number of buffers. And down here, don't worry about this, just worry about this method. Number of buffers. Yeah, we have to give it the amount of buffers we need, and as I said, we're going to be using 3. One that's shown on screen, one that we are writing to, and one to kind of be that buffer in between. So this is going to yeah, guys, just let me know if you need to compile and make sure stuff works. And if you need to see anything. Are we good? Yeah?
Add canvas, because that's only a comment make your frame visible. That's supposed to be above canvas, not
Oh, oops, yeah. Comments wrong. Make our frame visible should go above the set visible. Add canvas just yeah. A legal state exception? Oh yeah. Oh yeah, we haven't handled that yet. We're not done yet. Yeah. Don't worry about running. Just make sure it compiles at this point. Right now it's just detecting, because Java makes things easy for us, it's detecting the fact that we're not actually doing anything with our buffer strategies. We're just kind of creating it. So let's go on from that. We want to go ahead and get our buffer strategy. And I'm just going to go ahead and call a method, or sorry, a field here. Buffer strategy, buffer strategy is equal to canvas dot get buffer strategy. If I can spell things. And this is a method that just gets our, I think I spelled something wrong. Oh, we need to import buffer strategy. There we go. So let's go ahead and figure out what that is. I'll come back to that in a second. So create buffer strategy. Okay. strategy. Buffer strategy. And that is in java.auth.image.buffer strategy. So I'll just copy that over. And then you can copy it down. And there's that line first, if you need to copy that down. See if I can scroll it. Okay. So buffer strategy is going to go before this because alphabetical order. And of course I need import. So java.auth.image, image is lowercase. Not sure why. What? It's I'm ordering it by the last part of the import. So buffer strategy is before canvas. Although, yeah, I think about it, that would make more sense. You're right. So it would be, there you go. So we all got that line. Let's go back down to the other line. Canvas.get buffer strategy. And I think, how much time do we have? Not that long. Let's see what we can do. Okay, let's try and do something quickly to actually get a working program that runs the end here. So buffer strategy, we have that in our code now. So we're going to create a very, very bad loop. Actually, we have to do this after we set visible. Otherwise, we'll never set visible. We have to create a bad loop while true. Because our parameter is true right now. And the reason we're doing this is because we need something that loops and sets our graphics. So yeah, we have to do this. And we're going to go ahead and every single time this loops, we're going to get the buffer strategy from our canvas, because what this does is actually gets, I actually don't think I need to do that. I think about it. No. Let's go ahead. Instead, what we have to do is we have to set our graphics. We have to create a graphics component, and we have to set that equal to buffer strategy dot get draw graphics. So this gets the graphics for our specific buffer strategy. And actually, now I think about it, yeah, we do need to do buffer strategy is equal to canvas dot get buffer strategy, because that will get the current buffer for the current buffer we're on, the current buffer we're writing to. So those two lines will get our buffer strategy and give us the graphics from that. And then we can do the same stuff that I commented down here in a better way. Let me just copy and paste that up here. That's the reason I commented it, but you can do whatever you want. And then uncomment these lines. So we have a color there. And then there's one more thing we have to do. And that is down here, we have to do buffer strategy dot show. And this just calls a method in the buffer strategy to tell us that we're done with writing to that buffer. So it's ready to show that buffer. And that just means show doesn't mean it's immediately going to be put on the screen. It's going to be put in the queue to be put on screen. If you have two buffers, it does mean that you're going to be putting it on screen, but or one. But if you have three, it's going to be putting it in queue to be put on screen. It's actually kind of a vague method name now I think about it. It should be kind of like switch or switch buffer, swap buffer, just show. And one more thing we have to do. Actually, let's just make sure this runs first, because this should work. Ah, it's not working. Component must have a valid peer. Am I not doing something? Oh, wow, one thing we have to do, sorry, I actually had this in my notes as well, which is, I'm ashamed of myself. Up here, when we have, before we do canvas.create buffer strategy, we have to put our set visible line. So move that up before the, after the add canvas. Because it needs to, the buffer strategy needs to know that we have a frame. And one that it can actually attach itself to. So that works now, and I have my oval like I did before. Yeah, my other monitor is so much bigger than this one. After the add canvas, we want our set visible. So this does the same thing, but in a way that it automatically repaints every frame. And to test this out, if we were going to do double I or whatever is equal to, or actually I'll just do int I is equal to 0. It's just a random, you can, there's some reason I'm calling it vague is because we're going to delete it soon. We're going to just do I plus equals, or plus plus, do I plus plus. And then if I, actually how do I like this? Yeah, if I is equal to 1,000 or so, whatever, we're going to go ahead and set I to 0 again, and then we can do something else like create another variable here for the x position or something of the oval. And then do x plus plus every time that I is 1,000. And then down here for fill oval, we just put in x here instead of 200. That's just a test. You don't have to do this yourself. I'm just showing you that this this will automatically move. I think I made the number so big that it's not doing anything. Hold on. Let me go ahead. Okay. Yeah, that works. So there you go. You have a moving oval. And as I said, you don't have to do that test yourself. I'm just showing you that this works. If we just did the paint method, it would not repaint it automatically every frame. So here we have our oval. Goodbye, oval. The oval's leaving us. Okay.
And it's nice and smooth because it's in the buffer.
Yeah, it's nice and smooth because we're not drawing every. Yeah, that's your question?
So,
It's gone now.
why is the eye increasing at the rate of how often does the while loop occur?
It happens as much as the compiler or your processor can physically process it, I guess, or how much memory you give it. There's a lot of stuff, but it pretty much runs as fast as it can right now, which we are going to in later lessons. We're going to regulate that. But for right now, that's why I'm saying this is a very bad loop. Don't do. No, bad loop. This is a bad loop. One other thing that we're going to need to do, I guess you don't really need to do. I like doing it because it's sort of like when I got into C++, I had to deal with clearing memory a lot. We want to go ahead and call graphics at the end of everything after buffer strategy. Actually, no, before buffer strategy, we don't show probably be best. We're going to do graphics.dispose. And this releases the graphics system resources pretty much because we're no longer drawing to it. And I guess it doesn't really release the actual graphics that we've drawn. It just releases being able to draw to the graphic. So, and the reason we do that is because it doesn't sometimes clear it as fast as we want it to, and just gives us excess memory that we're using for nothing really. So, just to be safe since we're doing this a lot. So it's perfect because it has me right up to one of my stop points. So. I'll be in England next Thursday.
2 weeks is Thanksgiving. Right?
Yeah. Unless we did Tuesday next week. Tuesday
next week? Like 2 weeks.
Oh, okay. Tuesday and next week is the only day I could probably do, because I'm actually not going to be back until after Thanksgiving. Okay, then, alright. So, unfortunately, next one's probably going to be after Thanksgiving, because I'll be gone for next week and the week after.
So, for the good of the order, Marcus,
Yes.
buffer strategy is not public in components. cannot be accessed from outside package. Buffer strategy is not public.
You don't
So-
have, go back to your code.
Where's our problem? There's another substitute.
Yeah,
Would that do it though?
try, I don't know.
Because I think it, yeah, that actually probably will do it now I think about it.
What? No, it won't. There you go.
Do you have a,
There's yours.
Oh, Colin, you're a variable name.
Yeah. We have.
Not sure why it makes a brain behind Marcus, why do I have a nice little outline in the background? Oh yeah. As I have going down the street, it makes
Something I did not get into, unfortunately. We'll fix it next time. It happens to mine as well.
nice little outline.
Yeah, we'll get into that.
Sony's moved 60 frames a second.